This customer bring me two batteries to check. So first thing I will do, I believe it's to make sure that I will not be blind by doing this. So I'm gonna wear these nice glasses, right? That's the first thing to do. Second thing what I want to do is to see what I should do with this. So I think the first thing to do would be to look at the chart here, which is I have it. And it's written here. What I should do first is to evaluate the open circuit voltage. Open circuit voltage here will tell me voltage of the battery, all accessory off, key off. The open circuit voltage simply tell me the state of charge. The capacity test, if I could do that, will tell me if the battery will be good or not good. So first of all, what I'm going to do, I will just take a voltmeter. I will select it, voltage DC. I will make sure that my probe are properly positioned on my multimeter, the common ground, and the voltage I could see here, it's written V. And then I will make sure that my positive lead here will be on the positive of the battery, which is here, my negative lead on the negative of the battery, because I know that on the negative of battery I'm supposed to have 0 volt, and on the positive I'm supposed to have the voltage of the battery. The voltmeter will show me the difference between the two poles, and I'm reading here 12.87. 12.87, it's higher than 12.66, which is telling me, look, here it's higher than 12.66. Remove the surface charge, so I cannot assume that the battery is charged. I cannot assume it's not charged because the voltage is higher than 12.66. So what I have to do here is to see on number 2. They say apply half of the CCA for 5 seconds, let the battery rest or for 5 minutes or shake it. The idea of shaking it is to make sure that we'll mix the electrolyte in order to speed up the process of verifying again the open circuit voltage after the surface charge will be removed. To remove the surface charge, I have to find the CCA of the battery. If I look at the battery here, it's written 540 CCA, cold cranking ampere. And what I have to do is to apply a charge on it, which is removing from the battery half of this for 5 seconds. To do this, I need a carbon pile, which is right here. So what I'm going to do, I will just take my battery cable here of the carbon pile. I will connect the negative, positive. This will power up my machine. Then I will just unmix the wire a little bit. Take the amp probe. The sensor which is used inside the amp probe is called an Hall effect. And then here what I want to do is to connect this to one of the two wires in order to measure the amount of ampere I will remove that I could have the reading on the machine here, on the carbon pile. At that point, the position of the amp probe, this side or here or there, doesn't make any difference because I know I will empty the battery. So the only thing which is important will be to the number which is there. What I'm going to do, I will turn this until I will get half of the CCA, which is 540, so which is giving me 270. So 270, good. So I will go here and take 270. I try to have an average of 270, 3, 4, 5. That was 5 seconds. Normally my surface charge is supposed to be removed. What I will do now is taking the battery and shake it. That is to process, to speed up the process of mixing the electrolyte. Now I could look at my voltage. I am at 12.59. Almost, okay, 12.60. So if I come back here, 12.60, I am in between 12 and 45. I am coming from here, I'm going back there. I am in between here. So what I could do here is to go down there to proceed to B. Because I'm between 12.45 to 12.66, I could go to the capacity test. in order to see if the battery is good or not. I see number 3. This test measures the amount of ampere that the battery could deliver. And this is indicated by the capacity of the battery to retain its voltage, residual voltage. So what I want to do here is to remove half of the CCA from the battery for 15 seconds. And at the 15 seconds, I want to make sure I will record the voltage of the battery. This voltage will be called residual voltage. And that voltage will be applied on that chart here according with the temperature of the battery to know if the battery is good or not good. At this point, I will declare the battery good or not good for the customer. So I will be back here. I will again take my amp probe, connect the amp probe on the battery. My battery voltage went up a little bit, but because I removed the surface charge, I will accept that voltage as a full charge. I have a switch here that if I press on the switch, that light will come red. 15 seconds after will come green. That will give me an indication that the 15 seconds are passed. So I go again. I will just put my load. When I will see 270 here, I will press on the switch. I have to keep an average of 270. It's a little bit difficult because the temperature of the inside go up and down. 274, 270. I'm watching for that light here. Green, 9.6. My voltage was at 9 points, a little bit higher than 9.6. If I refer that card here, that chart here is written 9.6 at 21 degrees Celsius. I'm in the garage, and that battery was in the garage all night, so that battery is at the room temperature. At 9.6, I have to say my battery is good. What I would suggest to the customer, it will be to say, look, you are at the minimum residual voltage. A little bit lower than that, and I will have to say the battery is not good. So I will declare the battery good, but with a suggestion to say, you will probably have to change the battery in a few months, especially if it's very cold. But honestly, if I'm looking just at the technical point, I have to say that battery is good. Good? Residual voltage 9.6 or higher at room temperature. Now the customer brings me another battery, which is right here, that he wants me to check again. So I will do the same thing. I will take my voltmeter. Doing the same process, I want to measure the open circuit voltage. I have another chart here, which is a little bit bigger. So I could use the refractometer to measure the density of the battery, of the liquid, which will give me the same information as the state of charge, but that battery cannot be opened as much as this one, so I don't have access to the liquids. That's why I'm using the voltmeter. I will do the same thing here. Negative, positive. I have 12.19. If I refer to my chart here at 12.19, I am way below the 75%. 12.19, my charge of the battery is less than 50%. What I have to do now will be to charge the battery, because under 75% of charge, it's not a good idea to do a capacity test. So it's written here, lower than 12.45, charge the battery and return to A. So the process here will be to put the battery on a low charge for a long time. So I will say maybe something like 2 to 5 ampere for something like 45, 48 hours at least. And when that time will be passed, I will have to recheck my open circuit voltage and process to the same procedure. That's it. Thank you very much.
Pierre,
Yeah.
can you say ziggity doo?
Sorry?
Say ziggity doo.
What's that?
Your thing, you know, you say ziggity doo.
Ziggity doo.
Ziggity doo.
Why?
Thank you.